Good morning, one and all. I am Dr. Ramya Swetha, Assistant Professor, Department of Civil Engineering, Institute of Aeronautical Engineering. Coming to the as a part of ground improvement techniques. Today, our specific topic is Vibro compaction. Coming to this Vibro compaction, it is also known as Vibro flotation. It is also known as Vibro flotation. It is a ground improvement technique which is used to densify. It is going to densify the loose soils, granular soils, therefore increasing their bearing capacity and stability. So this is the one of the technique which we are going to use, enhance the bearing capacity as well as the stability of the soil, how much it is required for the construction of the project or for the construction work for the construction. So this is also known as Vibro flotation. In this technique which we are used, few types of soils only, not for all kind of soils. Those types are the densify this loose, it densify the loose and granular soils. So this method is particularly effective in sandy soils and is widely used in construction projects which are requiring stable foundations such as buildings, bridges, abandonment, so on so. So requiring the stable foundations for buildings and bridges and abutments. In this Vibro compaction, so the name we are going to compact. Vibro compaction, it means we are doing the compaction. Using this technique, we have some principle. So that is the name itself tells vibration as well as compaction. These two are the major principles. Based on these principles, this Vibro compaction is working. So in this, the primary mechanism of Vibro compaction is the application of high frequency vibrations to the soil. So the primary mechanism of Vibro compaction, so we are going to apply high frequency vibration to the soil. These vibrations reduce the friction between the soil particles, allowing them to rearrange into a denser configuration. So in this, we are going to reduce the friction between the soil particles. So this is the property which we are going to reduce using this technique for the soil. Between the particles, what kind of friction it is there. So that is going to reduce, it is allow them to rearrange the denser configuration. So once we are reducing the friction between the particles, it is leads to the denser configuration. It is going to rearrange all the things. So this is the one of the principle which we are going to use in our Vibro compaction. In vibration, we are done the denser we are getting the denser configuration of the soil which is required in that particular region, as well as the how much the requirement is there for the construction work. Now coming to the compaction, as the soil particles rearrange, the soil's overall density increases. The soil overall density is going to increases. This process reduces void spaces within the soil, leading to the improved load bearing capacity and reduced settlement. So this process reduces the void spaces. In this compaction itself, it reduces the void spaces within the soil, leading to the improved load bearing capacity and reduced the settlement. We know once we are done the compaction means, so the soil particles are made like this. So once the compaction is done, these are going to like this. So this kind of compaction we done, it means the coming to the soil property, the bearing capacity is going to increase, soil bearing capacity, is going to increase, and it is after the construction work or at the time of the construction, what are the forces, what are the different kinds of loads we are going to impose on that particular construction work. It is going to reduce the settlement. So this process reduces void spaces within the soil, leading to the improved load bearing capacity and reduced settlement. So these are the two things which we are going to understand in our principles based on the vibro compaction. So the one is vibration and the other one is the compaction. So components of the, what are the various components which we are going to understand in the vibro compaction system. So vibro float, power supply, rig, these are the components which we are going to understand in our vibro compaction system. The first one is vibratory probe or vibro float. In this, the core equipment which we are used in vibro compaction is the vibro float. So that is, we are used, and it consists of cylindrical steel tube with an internal vibrating mechanism. It has inbuilt internal vibrating mechanism. Such type of equipment is nothing but the vibro float. And using this core equipment, we are using this vibro compaction. It consists cylindrical steel tube with internal vibrating mechanism. In this, the vibro float is typically equipped with water jets at the tip to assist with soil penetration and particle rearrangement. So in this, the equipment water jet. So the jet of water, we know this is the jet of water. So in this, the jet of water, the collection of water particles at a time, how much the quantity is there. Every time the same is going to inflow. So in the tip, this equipment is with water jet. This is nothing but the jet of water, for understanding sake. So to assist for the soil penetration and also the particle rearrangement. So this is the one of the component which is involved in the vibro compaction system. Move on to the next component, that is power supply. An electrical or hydraulic power which we are going to use to derive the tool. So using this power supply is the one more component in the vibro compaction system. So in this, the hydraulic power or electrical power units is derived to vibro float. So already we discussed, it is with cylindrical steel tube with an internal vibrating mechanism. How that internal vibrating system is done? Using this power supply, whether it is electrical power or hydraulic power, which you are used to drive the vibro float for the movement of the internal vibrating mechanism. So it providing the necessary energy for the vibration as well as the jet. So we required whenever the jet of water is coming means based on the some energy. So this power supply gives that particular energy for vibration as well as the jetting also. So in this, an electrical or hydraulic power unit is used to drive the vibro float, providing the necessary energy for vibration and jetting. The next one is crane. So crane or rig is used to insert and withdraw vibro float from the ground. So we are using this equipment, cylindrical steel, and we are going to insert into the ground. So this is the one more component which we are used to insert the vibro float. After mechanism, vibrating internal mechanism, using this and using this power supply, and we are done all the requirements things for enhancing the soil bearing capacity as well as the settlement of the foundation and rearranging all these dense soil to, once the compaction is done. So all the components are happened. Now for that we are using for insert as well as withdraw the vibro compaction equipment using these cranes. So from the, it is also positions the probe accurately over the compaction area. It also helps where the position is required for getting the required enhancement for the vibro compaction, for getting the required soil properties. For that also it is also helpful for them where the exact positions are located. For that we are going to use these components. So these are the three various components which we are used for this vibro compaction. Process of vibro compaction. In this site preparation, the first thing we have to prepare this site. Where the compaction is required, we are going to mark those and how much depth the crane is going to move using crane is along with our vibro compacting equipment, the core equipment, how much depth is required to insert into the ground. After that, how much time it took, it depends upon the soil property, how much the sandy soil is there in that particular locality, how much we required for the construction work. All are the parameters we have to understand in this process of the vibro compaction. So what kind of water table is available there? Any kind of water tables are available nearby. How much water jet is required for the vibro compaction mechanism, and the internal vibration, how based on the power supply or based on any energies, how it is performance, based on the efficiency of that equipment. These are all the parameters we have to understand in this site preparation. So where it is, the points are needed, and how much spacing is required, which type of soil type it is, and what kind of enhancement of the properties, that soil properties required. These are all we are going to understand. Then only we are moving forward to the process. So in this process, we are first step is site preparation. So this site preparation is prepared by making the grid pattern. So we are choose the grid pattern where compaction points are needed. So it depends where the requirement throughout the site all over there's such kind of practical is not necessary in every time. So where we require that compaction, and we are going to identify by marking. So we are going to prepare for that points. So how much spacing of these points depends upon the soil type and the desired level of the compaction. So how much the compaction is desired for the required construction properties for the of the soil. So now the first we are going to prepare the site for the vibro compaction. The next step, insertion of the vibro float. We are going to insert the vibro float into the ground to the required depth, and water jets at the tip of the probe help in penetrating the soil, especially in dense or compact layers. So the next step we are going to understand. Once we understand, we prepared and we done the marking. After that, we are inserting this vibro compact and we are getting the how much layers we are required for the compaction. Next one is the next process is vibration and jetting. So once the vibro float reaches the target depth, it start vibrating at high frequency, typically 30 to 50 hertz. So the vibrations and water jet work together to fluidize the soil. Once we are insert these for the target depth, how much target depth we are consider for the construction. So the vibrations and water jet work together to fluidize the soil, reducing in particle friction and allowing particles to settle into a denser arrangement. So in this together, the vibrations as well as the water jet work together to fluidize the soil, reducing the interparticle friction. So once the friction is reduced between the soil particle, it is going to compact, and allowing the particles to settle into a denser arrangement. Once we have done this vibro compaction, in further settlement is not going to allow at the time of the construction. That is our motto for the vibro compaction technique. So for that we are going to process the vibro compaction very carefully, understanding this vibration as well as the water jets, how they work together and how much the fluidize of the soil, how much it is going to flow and how much it is going to allow the water. So reducing the friction and allowing particle to settle into the denser arrangement. So these are all the processes which we are going to understand in this process of vibro compaction. Now next, gradual withdrawal. This is also one of the proper process which we are going to understand. This is for gradual withdrawal and backfilling. So in this, the vibro compact float is gradually withdrawn in stages, ensuring uniform compaction throughout the soil column. So once withdrawn stage by stage, it ensuring the uniform compaction throughout the soil column. The process may involve multiple passes over the same area to achieve the desired density. So this gradual withdrawal is also the one of the step for the process of vibro compaction. If necessary, we are doing this backfilling also. It depends upon the project and depends upon the requirement. Not for all the cases, as per the necessity. In some of the cases, the granule material such as sand or gravel is added around the vibro float during withdrawal to fill voids and further enhance the compaction. So granule material such as sand or gravel which are going to added around the vibro float during the withdrawal to fill voids and further enhance the compaction. This backfilling process is not for all the cases. Whenever it is necessary, we are doing the process of the vibro compaction. This is not necessary in all the cases. That is, we have to understand in our vibro compaction. Now, how we are monitoring and control the vibro compaction? For this, we have different steps. So in this, monitoring and quality control is very, very important in vibro compaction type of techniques. In that, we have CPT and SPT tests. That CPT is nothing but cone penetration test. SPT is nothing but the standard penetration test. We are understand this monitoring and quality control by using these two tests. So the one is cone penetration test, often conducted before and after compaction, before and after this vibro compaction to measure soil density and verify the effectiveness of the treatment. So we have to test the soil before the vibro compaction and after the vibro compaction. We have to compare the soil properties in density and the effectiveness, how density point of view. Now we are going to understand how the treatment is effective, how much it is going to effective and how much it reaches our required parameter for continuing the further construction work of that particular site or locality or region, whatever it may be. So this cone penetration test we are going to conduct. The next one we are conducting, that is nothing but the standard penetration test. Provide additional data on soil bearing compaction and bearing capacity. So before and after the vibro compaction, we are collecting the samples and we are conducting the CPT test. We are understanding how effectiveness is there for the soil, as well as we are conducting the standard penetration test. Before and after, we are analyzing those two conditions, before and after vibro compaction, how the soil properties are going to change based on the compaction point of view as well as soil bearing capacity point of view. We have to understand the vibro compaction technique, how much effectiveness it gives for the after vibro compaction for the soil for required construction work. These are all the parameters we have to understand in our Vibro compaction monitoring as well as a part of quality control process. Now, settlement monitoring. So, these settlement plates or other instruments may be used to monitor the ground behavior over the time. So, how this settlement monitoring? So, once the vibro compaction technique is done, we have to monitor for understanding the ground's behavior over the time. Now, what are the applications of the vibro compaction? Coming to the vibro compaction applications, the one is foundation support, embankments and dams, liquefaction mitigation, land reclamation. These are all the various applications which we are going to understand in our vibro compaction. So, vibro compaction is used to improve soil conditions for building foundations, reducing the settlement and increasing the load bearing capacity of the soil. And it is helpful for embankments and dams. It is applied in the construction of embankments and dams to ensure stability and prevent differential settlement. Next one is we may apply this vibro compaction in liquefaction mitigation. In seismic regions, vibro compaction helps to densify loose saturated sand, reducing the risk of liquefaction during the earthquake. Land reclamation is used in land reclamation projects to prepare reclaimed land for construction by densifying the loose fill materials. Coming to the advantages of the vibro compaction, effective densification and versatility and speed. It is relatively quick, make it suitable for large scale projects, and also environmental benefits, reduces the importing fill materials as existing soil is used for the compaction. This effective densification provides significant improvement in soil density and strength, especially in granular soils. This effective densification, versatility, wide range of soil types and project requirements. The process is relatively quick. It means it comes under speed. These are the some of the advantages of the vibro compaction. Coming to the limitations, soil type. So, vibro compaction is most effective in granular soils like sands and gravels. It is less effective in coarse soils such as clays and silts. And coming to the groundwater, the presence of high groundwater levels can affect the efficiency of the compaction and may require dewatering measures. Coming to the noise and vibration, the process generates significant noise and ground vibrations which can impact nearby structures and communities. So, these are the limitations for some of the limitations as well as considerations for the vibro compaction. Soil type is also one of the consideration for most effective and less effective considerations of the depends upon the type of the soil as well as the groundwater level, and the noise and vibration is also plays a important limitations as well as the we are going to consider at the time of using this vibro compaction technique. So this vibro compaction is a powerful ground improvement technique that leverages vibration to densify granular soils, enhancing their load bearing capacity and stability. Its effectiveness, speed, and versatility make it a preferred choice for various construction and infrastructure projects. By understanding the principle, process, and applications of vibro compaction, engineers can effectively employ these techniques to address challenging soil conditions and ensure the success of their projects. So, this is a overall summary about the vibro compaction. These are the some of the web resources which we are going to understand for the vibro compaction in ground improvement techniques point of view. We are going to understand. Thank you. We will see in our next class.
Like, share and subscribe. Hit the bell icon for more updates.